In this lesson, we will solve logarithmic equations. So again, just as we did with exponential equations a few moments ago, we're going to solve logarithmic equations, and the way that we solve it will completely depend on how many logs that we have and how many constants that we have. So if we have a very simple logarithmic equation like this, notice we have just one log and then we have a constant. And when we do that, this is the easiest one because I can actually just use that little swirl method that we talked about before to call this 3 to the 5th equals 2x minus 1. It's the same as taking each side 3 to that power. It's called exponentiation, which we'll talk a little bit more about in just a moment. But this is the easiest way here. I use the swirly method. I use the base to the exponent equals the expression. 3 to the 5th would be 3 times 3 times 3, etc. And that would give me 243 equals 2x minus 1. I'd add 1 to each side. I would divide by 2 on each side, and that would be my value for x. So very, very simple. When it's written like this, just use the swirly method. If I have two logarithms, but I don't have any constants, notice there's no plus or minus 5 or 3 or any, constant value. The easiest way is to separate them by the equal sign, and then we're going to exponentiate each side. And what that means is whatever this base is, we're going to say this is 5 to the log base 5 of 2x minus 2, and this is 5 to the log base 5 of x minus 8. Now, why do I do that? Because we talked before about the fact that these really just cancel each other out. And so now I just have the equation 2x minus 2 equals x minus 8, which is a very simple equation to solve. I would subtract x from each side, and I would add 2 to each side, and I would get x equals negative 6. Now, one thing that you do need to be careful of with logarithmic equations is I know that I can't take the log of 0 or a negative power. And so if I plug this negative 6 in, I get negative 12 minus 2, which is negative 14, and that doesn't work. And it wouldn't work over here either. So this actually, even though I found the solution of negative 6, this would be no solution. So be very careful with those as you're working through your module in ALEKS this week. Notice here I have 3 logarithms, and it doesn't matter if they're natural log or common log or a log with whatever base. If there are 3 or more, but no constants, so again, notice I don't have any constants on the outside, we're just going to gather the logarithmic terms that have the x's, that have variables, all to one side. So I'm going to add the natural log of x, which gives me natural log of x plus 3 plus natural log of x equals natural log of 10. And the reason I can do that now is I can take this side and combine it. I'm going to condense it into a single logarithm. So we're going to use those properties of logarithms we talked about before. Because it's plus, that means this is a product. So I have natural log of x times x plus 3 equals natural log of 10. And then I will just take e, so I'm going to exponentiate again. And when I exponentiate, remember the base of a natural log is e, and so that's essentially going to get rid of this. So now I have x squared plus 3x equals 10. I know that in order to solve a quadratic, I'm going to have to move all of the terms to one side. So I have x squared plus 3x minus 10 equals 0. I'm going to factor that into x plus 5, x minus 2. And then from here, of course, I'm going to say that x equals negative 5 and that x equals positive 2 by setting this equal to 0 and setting this equal to 0. Then, of course, I will look back at my question and make sure that I can use both solutions. So if I use negative 5 plus 3 is negative 2. I don't like that. And over here, I would be taking the natural log of a negative as well. So even though I had 2 solutions, 2 is the only one that works. 2 plus 3 is 5. Natural log of 2, that's okay with me also. So 2 is my correct solution. Here's another type of question. So if there's 2 or more logarithms, and notice here I have a constant, it's going to be similar to what we did last time. I am going to get all of this together. So notice it's already on the same side. This is a subtraction problem, so this is actually log base 3 of x plus 6 divided by x minus 2 equals 2. And then I'm going to exponentiate each side. So again, I'm looking at the base here. I'm saying let's make this 3 to all of that power and 3 to that power. So this side cancels out, and I get x plus 6 over x minus 2. This side is 9. And then from here, I'm just going to solve. So I would multiply each side by x minus 2. So that gives me x plus 6 equals 9x minus 2. I would distribute. Get all of my x's to one side. So that would be 8x minus 18 on that side and 6 on the left. I would add 18. And I would divide to get x equals 3. And then again, I would double check. 3 minus 2, that works. 3 plus 6, that works. So my solution is 3. Here's another question for us to try together. Again, notice I've got 1, 2, 3 different logs, no constants. But I am going to gather the values that have an x to one side. So here, again, I would go ahead and move that 2 to the outside. So that's that other property I'm referring to in the title. So log base 3 of x squared equals log base 3 of 2 plus log base 3 of 3x minus 4. I don't like that I have x's on each side, so I'm going to subtract this value over. So I have log base 3 of x squared minus log base 3 of 3x minus 4 equals log base 3 of 2. This side, I'm now going to do some combining. This is subtraction, which means division. So this is now log base 3 of x squared over 3x minus 4 equals log base 3 of 2. Now we get to exponentiate. So notice each side is base 3, so I'm taking 3 to that power, which will get rid of all of that and give me x squared over 3x minus 4 equals 2. I would multiply each side by the denominator. That gives me x squared equals 2 times this, which of course I would distribute out. Knowing that I need to solve, I would combine or gather all terms to one side. So x squared minus 6x plus 8 equals 0. From here, I would try to factor numbers that multiply to 8 that add to 6. Negative 6 would be negative 4 and negative 2, which means my solutions, of course, would be both 4 and 2, and then I need to double check that that works. Here I've got 3 times 2, which is 6 minus 4, that's positive. If I use 4, 3 times 4 is 12 minus 4, which of course is also positive. So both of these are solutions for this logarithmic equation. There are 4 questions for us to try, 2 on this page and 2 on the next. So if you're working off the PowerPoints, press pause right here and try all 4 questions. If you are not, go ahead and try these 2 questions, then press pause, and when I show you the next questions, do the same. So for the first one, notice they're both log base 2, so I'm just going to exponentiate each side right away. That gives me 5x minus 1 equals 2x plus 17. I'll subtract 2x from each side, add 1, divide by 3. Double check to make sure that gives me positive values, and it does, so that's my solution. For the second, I would rewrite as 3x minus 4 divided by x plus 1 because it was subtraction. I would then exponentiate each side, so 10 to that power. That gives me 3x minus 4 over x plus 1 equals 2. I, of course, would then multiply each side by x plus 1. And I went ahead and distributed in that same step, which you can do or not do, it's up to you. I'm going to subtract 2x from each side. I'm going to add 4 to each side, and I get x equals 6. Plugging that back in, I find that those are positive values, and so that is my correct solution. Here are the other two questions. If you haven't had a chance to finish these yet, press pause, then press play to check your work. This question, I've got a 3 out front, and so whenever I have a value out front, it's actually easier to go ahead and divide each side by 3 rather than turn it into an exponent. So I've got log base 5 of 4x plus 1 equals 2. This is a single log with a constant, so easiest way is to say 5 squared equals 4x plus 1. 5 squared is 25. Subtract 1. Plus 1, so we subtract 1. And then divide by 4. If I plug it back in, it's positive, so my answer is okay. And last one, I have log. I've got a constant, I've got another log. I'm going to add this log over, so I have log of x plus 15 plus log of x equals 2. I'm going to combine this into one log because there's a plus, that means it's actually multiplication. So I have log of x times x plus 15. If you want to distribute on this step, it's completely fine. I'm going to exponentiate. This is log base 10, so I'm taking 10 to that power. On this side, I get x squared plus 15x. On this side, 10 squared is 100. I'm going to move it all to one side and factor. So I'm looking for numbers that multiply to 100, that subtract to 15. So that would be 20 and 5, x plus 20, x minus 5. Which means my solutions are negative 20 and positive 5. If I use negative 20, that gives me a negative on the inside, so that's not going to work. So 5 is my solution.